This is for Year 12 Specialists. It comes out of 2E. It's question 6C. We've already done 6A and B in a previous video. So 6D gives, given that OD, this is O to D, intersects AC, which is that diagonal at point E. So here's my point E. And that OE equals this. Now this is the rule for collinear, because collinear said that E would equal 1 minus m times A plus m times B, where m in this particular case is, C, where m is lambda, and OC is the same as C, and OA is the same as A, and E is the same as AC. So we're really trying to prove that these are collinear. Okay, so if I take this expression for OE, and it's going to be 1 minus lambda times AC, OA, plus lambda times OC. And that's going to equal 1 minus lambda times OA, which is minus 4i plus 3j, and lambda times OC, which is 3i plus 4j. So I end up with 1 times minus 4i plus 3j plus 4 lambda I minus 3 lambda j plus 3 lambda I plus 4 lambda j. And putting all the i's together, minus 4 plus 4 lambda plus 3 lambda gives you 7 lambda minus 4 in the I. And putting all the j's together, 3 minus 3 lambda plus 4 lambda gives you plus 3 plus lambda in the j's. So that's one expression of OE in terms of lambda. I'd like to find OE in another way. So what I'd like to do is I'd like to say that OE is coming to E straight up the middle here, where OE is equal to some proportion of OD. So let's say KOD. And I'd also like to come to E going via A, and that OE equal to OA plus AE and OA plus some proportion G of AC. I don't know what it is. So that will give me K lots of OD, and what's OD? OD is this one here, minus 2i plus 17 on 3j. So I've got minus 2ki plus 17k on 3j. And this one here is OA, so that's A backwards. So that's 4i minus 3j plus G times AC. And AC I've previously worked out to be 7i plus J. So that gives me 4i minus 3j plus 7gi plus gj, which is in the i's, 4 plus 7g plus g minus 3 in the j. OA is minus 4 plus 3. So I wrote, so that's minus 4 plus 3, so that's minus 4, that's plus 3. So if I was to solve this simultaneously, my I components must equal, so minus 2k equals minus 4 plus 7g, and my j, so minus 17k on 3 equals g plus 3, and on a calculator, and that's going to give me G equals 2/5, K equals 3/5. Now, if I look at this expression for OE, and I look at this expression for OE, which comes from this statement, then I can see, I get a copy of that. That lambda is G. 7 lambda minus 4, 7G minus 4, lambda plus 3, G plus 3. G is the value of lambda. Since lambda equals G, they equals 2/5. If you're interested in seeing how to solve these by hand, continue watching. I've got minus 2k equals 7g minus 4. Now I've got 17k on 3 equals g plus 3. So I've got 17k equals 3g plus 9, so k equals 3g plus 9 on 17. And then I'm going to replace that up over here, which will give me minus 2 times k, which is this, 3g plus 9 on 17 equals 7g minus 4. So minus 6g minus 18 equals 17 times 7g minus 4. 70 plus 49, 119g minus 2.24, 68 equals minus 6g minus 18. 119g plus 6g is 125g. 68 minus 18 is 50. G equals 50 on 125. Common factor of 25 goes 2, goes 5. G equals 2/5. Same answer. So it's using a substitution method. Okay, so G, or lambda, equals 2/5.